Okay, so after this power generations, we are doing the transmission and the distribution. So let us discuss about the approach, the various method for the power generations. So this generating power plant convert any other form of energy into the electrical energy, and the other form of energy may be the chemical energy, the solar energy, and the wind energy, or the nuclear energy. And these power plant, these generating power plants divided further in two types based on the intake, what the fuel they are taking to generate the electrical energy. It might be the renewable power plants, and it might be the non-renewable power plant or the conventional power plant. So the renewable power plants use a source of energy like the solar, wind, hydro, and the biomass. And this non-renewable or the conventional power plant use a source of energy like coal, nuclear, and the natural gas or diesel. And due to the limitations of the power generating resources, the generating power plant is located far away from the end consumer. So they cannot like this generations we cannot do close to the consumers. Yeah, I'm audible to all of you right now. Hello.
Yes, sir. Audible.
Yes, sir, you are audible.
Okay. So yeah, we let me come again on this slide number 2. So this we have generations, transmission, and the distribution. And for the power generations, what we do in the power generations, we use the we use the non-electrical energy, any other form of the energy, and we convert into the electrical energy. The other form of energy may be the chemical energy, solar energy, or the wind energy, or nuclear energy. And these power plants again divided into two types: the renewable power plants and the non-renewable power plant, or we can say the conventional power plants. The renewable power plants use a source of energy like solar, wind, hydro, and biomass. And the non-renewable or the conventional power plant use a source of energy like coal, nuclear, natural gas, or diesel. And due to the limitations of the power generating resources I mean to say like coal, we required in case we are doing generations from the coal based power plant, we require the hydro, we require the water. So due to the limitations of these resources, this generating power plant is located far away from the end consumers. So what is the voltage that we generate? What is my generation voltage? Due to the limitations of the generating equipment size, due to the limitations of the road transport limitations, equipment operation and maintenance limitations, the generating voltage of electricity is in the range of 3.3, 6.6, 11, 20, and 33 kV. Whereas the generating electrical power, the generating electrical energy is in the range of megawatt, 100, 300, 600, like this megawatt. So what we are doing, first of all, this generating power plant is far away, is located far away from the consumer. And second, due to the limitations of the equipment size, limitations of the transport, the generating voltage that is very less, 3.3, 6.6, 11, 20, and 33 kV. And most like preferred choice, we generate like maximum 11 kilovoltage generations. So we are doing generations a bulk power in megawatt scale, but voltage is 11 kilovoltage, and that is far away from the consumers. Hope my point is clear right now. So what we have to do now, we have to transmit this generating power. So let me ask one question: can we transmit the whole this bulk power, this megawatt generating power into the same voltage level whatever we have generated? So why not? Yeah, Gurjit, your reply is correct. We cannot transmit the same voltage, but why we cannot transmit? What is limitations in the transmission?
current will be very high. So electric requirement and cost will also.
The voltage drop, okay, high current value,
Conductor size constant.
high current value. So let us make a list. Why not we can transmit? So whatever we are doing this. Here we have this generator. This generating voltage is my 11 kilo voltage. This 11 kilo voltage we are generating, and after the this 11 kilo voltage we are generating, suppose here we have this consumer, here we have the consumers. Now we have to transmit the generated electricity to the end consumers. So that questions that can we transmit this 11 kilo voltage whatever we have generated? The answer is no, we cannot transmit the same generating voltage to end consumers. Correct. So let us make the point. First of all, since we are Genesis is 11 kilo voltage is 11 kilo voltage, and the power is in the range of megawatt. Suppose we have 600 megawatt, right? Voice not audible. Why not? My voice is not audible to you, Subhendu. Why not? Let me check with others.
Others, I can hear.
Yeah, Raghunath, what about you?
Sir, audible, sir.
Yes, sir. I'm audible. Yes.
Yeah, everyone audible, Subhendu. So please check. Yeah. Yeah. Check again. Yeah, it's audible to everyone. Okay. Yeah. So the point, the voltage is 11 kilo voltage. Genesis 600 megawatt. So how much will be the current? What will be amount of current? We know the formula that P is equals to root 3 VI cos phi, right? Let us convert this megawatt into the MVA. So what will be the MVA power? 600 divided by the 0.8. It will give the MVA power. Suppose we are taking, let us take 600 megawatt MVA. Let us assume 600 MVA we have the power that need to be transmit. So what is the problem? So again the formula of power will be under root 3 into V into I. We are taking power into MVA. So current, this 600 MVA power that we have, divide by the under root 3, that is 1.732 into voltage. Generation voltage 11 kilo voltage, right? So let us convert this MVA into kVA. So multiply by 1000, it will give the kVA. So kV cancel by kV. Let us find out the current, how much this current is coming. So any idea, anyone having the calculator? 600. So this is first class, but the next class please sit with the proper notebook, a glass of water and the calculator. 600 multiplied by 1000. Yeah, we have some reply. 31 kilo ampere approximately. Correct. So what is my current to be transmitted? 31,000 ampere. So if such a high current, what is the problem with this high current? Yeah, the problem is that the losses, that is mostly dependent on the current. The loss is going to increase very much, very huge losses in power. So your power transfer capacity decreased due to the losses, very huge losses due to this current, due to the huge transmission current, very huge losses. Second, what will happen? The equipment that we are using, like the conductor size going to increase so that they can carry this 31,000 ampere current, and this is the continuous current, not the fault current. So it is the continuous current. So conductor size going to increase. If the conductor size increase, then the supporting tower, the structure cost going again huge, and when your tower size increase, then your ROW, your like right of way, your land requirement again going to increase. So the point that we cannot transmit such a huge current, such a huge power on the low voltage, this we cannot transmit. Losses very much high, conductor size going to increase very much so that they can carry 31,000 ampere. Okay, and again the receiving end voltage, it's very less. Okay, so the conclusion that we cannot transmit this power. Okay, so how we transmit the power then? What is the method that how we can transmit the power? What we have to use here? So we have to add here one generating substation, and here we have to add one distribution substation. So what I will do, or what we will do, we will put up here one transformer that will be the step up type transformer. So whatever voltage we are getting, power keeping the same, but voltage we are going to increase. How much going to increase? How much voltage we have to increase? Based on the power transfer, how much power we are going to transfer, and based on how much distance we are going to cover. So we have to increase the voltage with help of this generating substations, with help of this step up type transformer, so that when my voltage is going to increase, power is same. If my voltage increase, then what will happen? Current going to decrease. So when my current decrease, losses decreased, conductor size decreased, the tower dimension decreased, the land area decreased, right? So, and to step up this voltage, here we required one step up type transformer and with associated switchgear, and for that we make here one generating substations, generating switchyard, or we can say the generating substations. Here we will make, and since we have step up the voltage for the power transmission purpose, here's whatever the voltage we are taking, this step up voltage, suppose we step up to 220 kilo voltage, or we step up to 400 kilo voltage for the long transmission. So again my consumer, my end user is not 400 or 220 kV, so we have to again step down this voltage. So here we have to use one transformer that will be step down transformer. So we step down the voltage and then we again distribute further to the end consumers, right? Clear now? This point is clear, why this substations here and why this substation over here. I need one engineer who can at least reply and who do not have the background noise. Yeah, Rag.
Yeah, this is okay. Yeah.
So,
Yeah, so clear.
so we are discussing the background of the course, and after that I will come on the course, the background of the electrical system. Since this is since today we are starting the batch, today we are starting this program, so that's why what the background, what we have done study during our academic time, during the undergraduate or postgraduate, what we have done study, and after that we'll come on the this syllabus and topics. Yeah, so this, since generating voltage level is very less, max to max 30 kilo voltage level, and these generating stations located far away from the end consumers. Therefore, if we transmit the bulk power in less voltage, as we discussed, if we transmit the bulk power in less voltage from generating plant to the end consumers, since there will be long transmission length to be covered by this low voltage, and the receiving in very low voltage, and therefore low power received, and due to low voltage at the same time current will be higher due to the low voltage current higher, and thus the transmission line losses very much higher and less power transfer capacity possible, right? Transfer capacity possible. Therefore, to increase the power transfer capacity and to reduce the line losses, the generating voltage need to be stepped up, and so to step up the voltage, generating substations will be required with the step up type transformer and with the associated switch gears, whereas electricity travels more easily at high voltage because there are less energy or fuel energy losses. So if we step up, then the power transfer capacity going to increase. To connect these remotely located power generating plant to the end consumers, we need the chain of substations, generating substation, grid substations, and distribution substations. Because what happens, these power, with help of these two substations, we cannot take, we in between we have other grid substation also. Here we apply the grid substation also, so that if there is any another geographical reason, so with the help of the same transmission line, we can feed to the nearby geographical region also. So we required some intermediate or the grid substation also we use. Why not audible? Yeah, Abhishek, audible to you, Abhishek? Acha. My internet quality is good. If anyone not audible, so they again join. So you check your internet, or you again join with the same link. Okay, so I have the good internet speed. I'll come on that. Distribution side, the voltage 400 voltage, or the 11 kilo voltage, or 33 kilo voltage at the distribution side. Okay, say it. Yeah. So we are discussing that since we cannot take only two substations, generating and the distributions. For example, this transmission line is traveling 400 or 500 kilometer. Okay, so we use some intermediate or the grid substation, so that the nearby area also we can feed. So the power transfer, with some series of the substations, generating, then grid or intermediate substation, and the distribution substations, and the transmission line, and finally the distribution line to feed finally to the end consumers. And combination of this network, substation, transmission, and distributions, we called as the transmission and distribution Tnd system in the industry. This is the Tnd system, or the Tnd job. This is one segment of the electrical Tnd system. So hope what we discussed, the meaning of the Tnd word over here, and why this Tnd word, why this Tnd industry we have. Clear now? Let us make some takeaway point what we discussed. After this class, what is our takeaway point? Yeah, so we discuss about the background of the Tnd, and what the system involved in the Tnd, and why this Tnd system is required. Okay, and the rating of step up voltage decided based on the power to be transmitted and the length to be covered by this electrical this power. So let us have some look of the chain of the substations. Below is the snap of chain of the substation: power generations, then EHV substation, this power primary substation, secondary substation, the pole mounted substation, then we are feeding to the end users, and here we are power generations by other source, and we are feeding to the same network. Okay, we can have one look of the chain of the substations. There is one link, so that we can do this. We can have a look on the power grid. Let me paste. The power grid, the Tnd system. So we can simulate, we can see by this. Yeah. Yes, so what we are doing basically, this coal 600 megawatt we are doing generation. Here we have this nuclear. Let me put on this nuclear on. Then wind farm. Okay, then we have this hydro electric. So by the different power generating mediums like coal, nuclear, wind, hydro, we are doing the generations, and we are feeding to this power grid network. This network comprises of this transmission line and these substations. So from generations we are doing this substation 3, 2, here we have 1, this external system it is going, and these substation, this chain of the substation is interlinked to each other. They are interlinked to each other, so that suppose this my commercial demand increased, suppose demand is 300 megawatt as of now. Okay, this substation 5 is taking 200 megawatt from this substation 1, 200 from here 9, and then 300 they are feeding over here. If this demand increase, suppose this increase to 350 or 400 megawatt, then this they are taking now 249 megawatt from here, 200 megawatt from here, 200 400 they are feeding to this, and 49 they are feeding to this, 50 they are feeding to this. And so what we do for the security of the power supply, for the reliability of the power supply, this substation and the transmission network is interlinked to each other. Is it clear what I'm trying to say? And these chain of the substation, through this we are doing the power transfer. So what we are going to study in this training program, to how to make the construction drawings for these substations, for this transmission line, and some system study with help of the ETAP software. And we will make this drawing on the AutoCAD, with help of the AutoCAD as a drafting tool we are using. So far I think I'm clear. Are any questions for me?
Yes, sir. Clear.
Yeah, thank you, Bahadur. Abhishek, Akshay, Anirban. Yeah, thank you. Thanks, Bandhu.
Sir, there is one question which I have. In terms of generating sources that we have, like, is there a maximum or minimum capacity for like coal or wind farm or the nuclear, or it depends on what we are getting at different locations?
No, actually, this generations depend on the resource availability, not on this network. This generation depend on the resource availability, that how much resource you are the available we have. Based on that we can do the generation. Am I clear? Say it right now. So it's not depend on this network, it's depend on my what source, how much resources we have. Based on my resources we plan that what, and based on my like fund, how much investment we are going to plan. So based on the investment, based on the resource availability, we plan the power generation.
Okay, thank you.
Yeah. Okay. But again we cannot LCS, Suresh, LCS the standard for the various capacity. Yeah, sure. And how much power we are generating as of now, so that also we can check through the CEA. There is Central Electricity Authority of India. From that website, how much power we are generating through the various resources, how much coal, how much wind, how much solar, how much hydro, biomass, nuclear, that all list we can check through the CEA, Central Electricity Authority. So total generations we can check from this CEA India, Central Electricity Authority. From that we can check this conventional capacity, renewable capacity, addition. So through that we can check transmission and how much additions, what's new. So from here we can check how much power we are generating as of now. Every country have their own grid, so based on the country grid practice we can see. Okay. Yeah. So chain of the substation, and this is the overview of the Tnd system. So we have this generation, then transmission substations, then transmission line, then distribution substation, distribution line, then finally industrial commercial consumer and the residential consumer. So these all network is the whole Tnd system, right? So purpose of this Tnd system, purpose of the substation, why we are using the substation, transmission line and the distribution line, what is the purpose, why we have, or we can see the power system component. The substation, why we have the purpose of the substation, the purpose is to step up the voltage at generating stations called as the generating substation, and step down the voltage at the consumer end, or we can say the distribution substations. So step up, the purpose of the substation is to step up the voltage at generating power plant station with help of the generating substation, and step down the voltage at consumer end with help of the distribution type substation. So this is the purpose of the substation. Transmission line purpose, so purpose is to transmit the power over a long distance, right? And there is two type of the transmission, primary and the secondary transmission. What is the transmission line voltage? So the voltage is starting from 66 kV to 765 kV. This voltage is called as the transmission voltage, and voltage up to 66 kV or 33 kV we call the distribution voltage. And then we have the distribution line. Further two types, the primary distribution, purpose of the primary distribution is to feed supply power to industrial consumer and to big consumers, and the secondary distribution purpose is to feed supply power to domestic and the small end users, and the distribution voltage is 33, 11 and 415 voltage. Say you have asked about the distribution voltage, so you can note from here, right? Now let us see the generating substation. What is the generating substation? This type of the substation gets the power supply directly from the generating plant, first of all. So this directly take power from generating plant. Here we have this thermal power plant, so taking supply from this alternator or this generator, and after that we make the switchyard. This is switchyard for the generating power plant. And here we have one example of the solar power plant. So here we have this generating substation or the switchyard, solar switchyard, solar substations. They are taking supply from directly from this PV cells, from the inverter duty transformer, and then they are doing transmission further to the network, to the grid network. So this type of the switchyard we called as the generating type switchyard or generating substations, right? So it uses a large power transformer for increasing the voltage level for transmitting and to long distance. The generating substation connect the generator to the utility grid. So that is the purpose of this overall purpose of this generating substation. Now after that we have the grid substations, the intermediate substations. The grid station is an interconnection point between two transmission line circuit. Those are serving or connecting two different geographic regions. So that is use of the grid substation. So we take the tappings from existing transmission line and we make one substation, grid substation, and we feed the local nearby area. So this is the grid substation, and this is also used to enhance the power quality, to enhance the voltage regulations, and they provide the better transmission line maintenance facility also. So this is use of the grid substations. The grid substation basically made by, so this substation, who will make this type of substation? The company that making the generating plant, thermal or hydro or solar, the company will make this generating substation by their own like expenditure. And this grid substation, this is made by the country grid company. In India we have the PGCIL, Power Grid Company. So in India, the PGCIL basically majorly make this type of the grid substations. Every country have their own grid, and the grid company basically make this grid substation. Their voltage level is higher, like 220, 400, 765 kV, like this the voltage level is higher. And then we come on the distribution substation. This is made by the state utility or the state electricity company, this distribution substations. So this distribution substation take the power supply from the intermediate or grid substations, and by the local utility, by local power generations, and then they feed supply finally to the consumers. So the distribution substation reduce voltage to a level suitable for the local distributions. Thereafter, the electricity must be distributed to each house, factory or the business. So what they are taking supply from their nearby generation or the grid. Then they step down this voltage suitable for the distributions. The distribution voltage is 1133 kV, and then they distribute these feeders. And again we have this pole mounted substations, pole mounted distribution transformer. What is the rating of this pole mounted distribution transformer? Generally we take 250 kVA approximate. Okay, and then they step down this 11 or 33 kV to 415, and then finally distribute to the consumer, to end user. So we'll cover this distribution substation, we will cover this grid substation, we will cover this generating substation. These all type of the substations we will cover and we will discuss in the class. Okay. So again, let us have one conclusion. Why do we have substations? The conclusion is that the purpose of substation is to step up the generated low voltage electricity from the generating system and enable for transmission, and then receive the power from transmission system and step down the high voltage to lower voltage electricity, so it can be easily supplied to end consumers like industrial consumer, domestic consumer, and through the distribution line. So that is the main objective to have the substations. Now next, so here we discuss type of the substations based on the locations. Again we have type of the substation based on the insulating medium or based on the installation. So we have the outdoor type AIS type substations. This is outdoor AIS type substations. Then we have indoor GIS type substation, this GIS, gas insulated substation. And then we have this hybrid type substation, the mixture of AIS and GIS we call as the hybrid type substations. The purpose, why this three type? AIS type take the longer, the higher installations area. So when we do not have the area, we have less area, so we can go on the hybrid type. You can see here the comparison, 20 meter for the same equipment they are taking 12 meter, because they have some hybrid equipment. In the hybrid equipment they are using the subsistence gas as the insulating medium, so the clearance is reduced and then overall equipment dimension going to reduce. So this area requirement is reduced. And then again, if we do not have such a area, such 12 meter space, again we can make one compact indoor type inside the building we can place, so that we have the GIS type substations. So we will discuss both AIS and GIS, both type of the substation we will discuss here in the class. Cost effective is now is AIS, but reliable is GIS. And nowadays, due to the higher competitions, the GIS cost also going to reduce. The difference between AIS cost and GIS cost, initially it was around 2 to 3 times, like 5, 6 or 10 years before, but nowadays due to the huge competitions in the market, the cost not 2 or 3 times difference between AIS and GIS. The cost difference is around 1.5 to 1.3 times higher of the GIS, right? So this, so we'll discuss both AIS and both GIS types substations. Yeah, Suresh, hope you got the reply. It's clear. Cost effective is AIS, okay, but when we do not have the land availability, in that case we have to go to GIS. The cost difference is approximate nowadays is 1.2 1.3 times. Initially it was around 2 to 3 times, but due to the huge competition the cost of GIS decreased. We have many manufacturers, so now the cost is decreased. Yeah, the AIS is easy to identify the fault, Bharti. AIS is easy to identify the fault and to do the maintenance. GIS is not easy to identify the fault and do the maintenance. We will do the comparison also, AIS and GIS comparison. Okay, we will have discuss the comparison between AIS and GIS and what is better, what is not better, and what is the place where we have to go only GIS. Like if you see the country like Saudi Arabia, the Gulf country like Saudi country, they have only GIS. They do not have AIS type substations. Why they do not have AIS? Why they have GIS only? We have some student from the Gulf also. Gurjeet, any other? They have the very polluted environment. They have the this dust storm. So due to the dust storm, yeah, Ismail, yeah, Ismail, you say yeah. Yeah, mute, unmute, and then you can speak. Ismail. Yeah, Ismail, you were from Saudi character. You tell me na. Okay, so the only have GIS. Yes, same Gurjit I was telling that because they have the dusty environment, they have the storm, so the AIS is not reliable in that place. So the Saudi go with the GIS only. Or we have an industry that is very polluted industry. In that case, also we go with the GIS. So we'll discuss anyway. We'll discuss both AIS and GIS. Okay. So everything will be covered. AIS, GIS. Okay. This grid substation. Yeah. The grid substation. This distribution substation. The grid substation. This generating substation. Everything we will cover. So that's why I'm discussing the background of this Tnd, background of the generation, transmission, distributions, so that first of all we know what is total overall system, generation, transmission and distribution. Then out of this system what we are going to study, right? So we'll discuss both AIS and GIS in the class, right? Now to make any AIS or to make any GIS type substation, what kind of the document, what kind of the drawings required for construction of a substation project. So as the design engineer, we need to prepare the following list of the document, drawings and calculations for construction of a substation project. Single line diagram, that is the first drawing. Electrical equipment, this electrical layout plan and section drawing. DSLP calculation. DSLP stand for the lightning protection, direct stroke lightning protection calculation and the drawing. Structure layout plan and section drawing. So this structure layout electrical not will prepare. This is prepared by the civil department only. The civil engineer going to prepare this document. Yeah, Suresh, okay. I will share this, sir. You can also check. Let me zoom. Whatever we are discussing here, everything we will share. Okay, so you can have a look. Now is it clear? Suresh, is it fine? Yeah. Anyway, I will share this list. Okay, I will share. I have taken the snap into PPT, but I will share the list also. Let me take the list here. Let me take the original list. Okay. 1 second. Let me take the original list of the drawing document required. Yeah, so here we have the original list, single line diagram. This we have to prepare electrical layout plan and sections, DSLP calculation and the drawing, structure layout plan and section drawing, but this not by electrical, this is done by the civil department. Okay, foundation again not by the electrical, they will done by the civil, but cable trench layout by the electrical only. Earth mat design calculations by the electrical only. The electrical will do the design calculation and the design and the arithmetic layout drawing both by the electrical only. Erection key diagram, this electrical only. The type test report for the bus post insulator, tension and suspension string insulator hardware assembly drawing, short circuit force calculations by the electrical, span calculations, bus power design calculations, continuous strength calculations, while investigation report. This is by the agency. We hire one agency for that, but that report we have to review. So these list of the drawings, and for the equipment that we use in the substation like circuit breaker, their GA drawing, GTP. GTP stands for the guaranteed technical particulars, and the type test report. So every equipment GA drawing, GTP, type test report we have to review and we have to approve, and same drawing like we have to submit to final client, the owner of this plant, owner of these plant, and they will again, the client will again review and they will approve. So this document required circuit breaker, this document required by the circuit breaker vendor, by circuit breaker manufacturing company like Siemens, GE, ABB. So that document we have to take from the vendors, but we have to review.
1 minute, sir. What about the GTP drawing?
GTP Bahadur, the technical particulars, this technical data sheet.
Okay.
Yeah, CT and CVT, GA drawing, GTP, type test report, surge arrestor. So what equipment we are using, each equipment drawing we have to take and we have to review, and we have to take final review from the client also. The control relay panel, SAS automation system, visual monitoring system, PLCC fire protection system, LT switchgear, battery and battery charger, DG set, AC, HAC by the HVAC team, civil work by the civil team only. So these are the documents, list of the drawing and documents. It is required for the construction of any substation project. So we have to make these drawings. So during this program, during this training program, whatever we have syllabus, during this training program we will discuss how to make these kind of the drawings and documents, how to review the equipment drawings document, how to make the drawings, how to make the calculations. So these all we will discuss and we will learn in the detail. Now let us move when any job opening come in the market. So what is the roles and responsibility desired by companies, and what is the JD job descriptions comes in market for the design engineer. So I have taken some snapshot of some JD by company so that we can have a look of that JD, and in line of that JD we can do our preparations. So we have taken one company, that is Vadodara based company. They are hiring for the design engineer substations. Roles and responsibility of that design engineer they have put here, the eligibility and the experience, right? So the candidate should be well versed in designing substation, power system and the transmission line. So that all we will discuss. From 11 to 765 kV we will discuss, from 11 to 765 kV every voltage level we will discuss. Okay, what is the voltage range? What is the voltage range? Let's know the voltage range also. Let's have a look on the voltage range. Okay, so generation is 11 kilo voltage, right? Maximum generating voltage 11 kilo voltage. Then after, what is the range of the voltage we have overall? I am waiting some reply. 765 that is the highest voltage. Okay,
1150.
1150, yeah, that's the highest voltage, 1150. Okay, in India, and that is the highest voltage in the world also as of now. In China they have 1100 kilo voltage, but India we have 1150 kilo voltage. That is the highest voltage across the world. Why we have such a huge voltage? Because we have a huge populations and we have a huge geographical regions. So that is why the variety of voltage is very much higher. If we go in Saudi Arabia, in the Gulf country, they do not have even 765 kV. Their maximum voltage is 380 kilo voltage. Right now, Gurjit. The Gulf country maximum voltage is 380 kilo voltage only. They do not go on 765 kV because they do not have such a huge geographical region. Yeah.
So Saudi standard is the American standard and Dubai standard is the British standard. So they are using maintain and Dubai and India is using the British standard for
400 kV. Yeah.
Yes.
So 400 kV like this. Let's okay. But India we have up to 1150, and that is the maximum. And maximum in the transmission stage is 765 kV. As of now, we are doing transmission, and we are utilizing that substation also we have. Let me go 1 second. So please make a list.
Is the voltage that's being defined, is it dependent on the type, like is it AC or DC, isn't it?
Yeah, yes, isn't correct. So we are talking about the AC voltage. You are correct. We are talking as of now for the AC voltage. I'm expecting some reply for the various range of the voltage that we have. In meanwhile, I'm searching some standard for that. If I found, I'll share the voltage range. Yeah, so there is one standard IEC 62271, and based on that IEC standard, and let me also note one more point, what standard we are going to discuss. Okay, we'll come on that later on. 6.6 kV. Okay, no issue. So we have this voltage range 3.6 across the world: 3.6, 7.2, 12, 17.5, 24, 36, 52, 72.5, 100, 123, 145 kV, 170, 245 kV, and different country adopt the different voltage level and voltage based on the current practice in some area like the North America and they adopt this kind of the voltage. Okay. So the voltage range that we have, this is 11 kilo voltage, starting from the generation 11 kilo voltage. Then we have 33 kilo voltage. This also we can generate 33. Then we have 66 kilo voltage. Then we have this 110 kilo voltage. Then 132 kilo voltage, and then 220 kilo voltage, 400 kilo voltage, and 765 kilo voltage, and the 1150 kilo voltage. So these all voltage level we will discuss. 1150 is not very much in the practice. This is under the R&D stage only. Up to 765 kV it is in the operations. So from 11 to 765 kV, every voltage level we are going to cover and we are going to discuss. Okay. So yeah, sorry. So the job opening 765 kV. So every voltage we will cover from 11 to 765 kV. So intermediate voltage again we will going to cover. Yeah. So yeah. So what the type of the voltage, and this again we can divide this type of the voltage as the LT voltage, LT, HT, and then extra high voltage, and then ultra high voltage. So the voltage up to 1 kilovoltage, up to 1 less than or equal to 1 kilovoltage, this voltage called as the LT voltage. The voltage up to 33 kilovoltage we called as the HT voltage. So 11 and 33 kilovoltage it will come into the HT voltage, and the E extra high voltage 66 up to 132 kilovoltage, like 220 kilovoltage, this come into the extra high voltage, and the 400 kilovoltage 765 kilovoltage, this comes into the ultra high voltage. So these are category based on the LT, HT, EHV and UHV. Okay, Suresh, clear? You ask about this. Is it
Nice.
yeah? So anyway, let us have the roles and responsibility required to the company. shall have a strong fundamental base of the substation design calculations. So we will discuss about the calculations. So you learn here. Physical layout preparations, again we will discuss the physical layout preparations. Okay, and let me take 6.6 kilovoltage and 3.3 kilovoltage, both we call as the medium voltage. Let me take the syllabus also. Yeah, so this single line diagram, let me go to the match with the job descriptions. Shall have a strong fundamental base of this design calculations, physical layout preparation, protection and the control philosophy for substation. Shall be proficient in ETAP. So ETAP we will discuss in the class. We have one dedicated modules. We have one dedicated part for the ETAP. So this part number 4, electrical system study software ETAP study. So software introduction about the ETAP. This ETAP load flow analysis, capacitor bank sizing, reactor selections. This so introduction, load flow or power flow analysis, short circuit or fault current calculations, the relay coordination. These are the basic fundamentals of the ETAP system studies. So that also we will cover in the syllabus. We will discuss in this training program. And AutoCAD software, again we will cover the AutoCAD software for the drafting purpose. Okay, so the engineer must have this fundamental base of design calculations, layout, protection, control philosophy, substation, proficient with in ETAP and AutoCAD. Okay, so ETAP AutoCAD link also I will share with you. You can download in your computer and you can do the practice by yourself also. We will be responsible for handling independent project. So what I do, that I'll share some live project, and you do the practice on that live project, so that you are like have confidence how to handle the independently a project, the designing part of that project. Client interactions, interface and coordination with the other department, site supervision on ongoing upcoming substation with transmission line project, should be proficient in English and written and spoken. So these are the roles and responsibilities. So our syllabus is designed based on these roles and responsibilities. We'll cover each and every topic from here. Let us have
Excuse me.
Yeah.
I have one doubt. Actually, in the ETAP, how we are going to manage whether we all have to have the software in our laptops, or how we can do the package?
So there is two things, Suresh. I'll share the link. You can download in your laptop if you have the laptop. If you do not have the laptop, so we will share the method here how to handle. We will share the steps with you, so you can note down that step.
It's like a free software available, or how it is?
We will share you links. Suresh, don't worry.
Yeah.
We will provide you software.
Oh, great. Thank you.
So you don't worry about that. Whatever we are learning in the class, IEC, IEEE standard, the software, each and everything, we will share with you. Okay,
Right.
only you have to work on that.
Yeah, sure.
Okay, so I have taken another job descriptions that come into market. That is this was for the engineer, and this was for the manager, the design manager. And I have taken the solar power plant company, the SB Energy. Hope the engineer who work in the solar, they know about the Soft Bank Energy company. I think that is Japan based company, right, Abhishek? Hope you are aware about the Soft Bank Energy. That is Japan based company. They have office in Gurgaon.
Yes.
I think the Renew Power have take over, or who have take over this? Something.
No. Adani.
Adani have take over on the SB Energy, right?
Yes.
Okay.
Yes.
So I'll share some job description for the SB Bank Soft Bank Energy. This company is in Gurgaon. Yeah. Now Adani, like just a few months before they took over this company. So let us have a job description of this company. Engineering support. So being a manager, what is your responsibility? Preparation of development of EHV system single line diagram. Let me come on the syllabus. Okay, so ETAP, I'll show you ETAP we are covering. Now coming on this other part of the syllabus. Single line diagram. As a manager, you need to prepare the single line diagram. So you can see that we are covering this single line diagram for both AIS and GIS, both type of the substation single line diagram we are covering. So SLD is covered. SLD is covered as per the job descriptions. It is covered in the syllabus. Okay, SLD is covered based on the job description. Design of switchyard layout, plan, section, EKD, clearances diagram. So for that we have this module. We have layout module number 6, layout preparations, layout drawing preparations of substations. So electrical installations, clearances, AIS substation layout plan and section, elevation section, so AIS and GIS, so control room building layout, estimation of plot, land area requirement, okay, and substation material sizing, equipment support structure, transformer, oil burn, oil pit. So these all short circuit force calculations. Short circuit force calculations required here. If you see in the drawing, they required the short circuit force calculation, so that also we are covering over here. So this covering the equipment sizing. Yeah, for the equipment sizing we have one modules, the module number 2, equipment selection, sizing calculation, the case study. Case study by the ETAP we will do some simulations. So the equipment sizing also we are covering over here. Equipment sizing, sag tension calculations. The sag and tension calculation we are covering the transmission line module. So here we have this sag tension calculations, so that we are covering. Insulation coordination study, we will share the document for that. Preparation of technical specifications, we have to prepare the technical specifications, so that we are covering into the project module. Preparation of substation equipment purchase order specifications, other inquiry specifications, so that we are covering. Okay, technical specifications. Okay, vendor drawing review, so we will discuss the vendor drawing review, each vendor drawing review, study and review method for vendor commercial offer, vendor offer, and here we will discuss about this vendor drawing review and comments for every equipment we will discuss. So vendor drawing review also we are covering. EHV system, transformer, cable and switchyard. So transformer also we have one module, dedicated module on the transformer. So the vendor drawing review, selection, sizing of transformers we are also discussing in the syllabus. Cable and switchyard, so cable we have one dedicated module for the cables only. So this is cable selection, sizing, that also we are discussing, we are covering. Okay, and design engineering process including all database, report management. So these are other managerial work. Desired profile, expert in the various EHV system, AIS, GIS, transformer, cable, switchyard up to 400 kV, 765 kV preferred. We are discussing up to 765 kV. So you are covering. Subject matter expert for EHV system component, so that we are covering. You will be subject matter expert for the EHV system. You have to follow our 3 to 3.5 month, and you have to revise the class, and you have to do the practice on the project. You will have the expert level knowledge of this equipment. Knowledge of Ais and Gis system, that also will cover. And hands-on experience of overall design, quality and the code checks, so that we will also take this code, we will have the checkpoint, and we will discuss on that. Sound knowledge of relevant engineering codes and the standard, that also will discuss the engineering codes and standard. And every engineering code and standard that we use in substation, I will make sure that you all have in your computer, all in your laptop. I think I have shared some engineering codes and standard also for equipment, at least I have shared right now. So that also I will discuss and I will share with all of you. You can have in your laptop. Knowledge of control and protection is desirable. So the control and protection also we are going to discuss. We will discuss about the control and protection also. Protection here we have. So the protection desirable, but we will discuss the protection also. Okay, some part they have not written in the job discussion, but that part is required in order for the project completion. That also we are going to discuss, like the lighting designing, it will be required. Lighting protection DSLP, that also will discuss. So this syllabus is more whatever required into company. Okay, so based on the job descriptions and specifications that we have reviewed, okay, by companies and based on the design engineer roles and responsibility in a project and based on the list of drawing and documents required. So this list of document and drawing required to be prepared by a design engineer for any substation project construction. The course is divided into 5 parts and having total 25 chapters are the 25 modules. So we can have a look on the course that we will discuss. So hope you now understood the background of this syllabus, right? The background of this content. Why this we will discuss, why we are going to study about that. So this 1 hour I spent to explain you why this syllabus you are going to study, and we have taken a lot of time to finalize this content. So based on the project requirement, based on the job descriptions, this syllabus content we have finalized here. So it will be 100% is based on the practical only. Okay, yeah. So let us have a look for the syllabus content. The module number 1, that is the introduction of the project, introduction of the complete process of the substation construction, process from tendering to energizing, and make listing of all construction and drawing needs at site. So that is the introduction part of the project that we will discuss. Module number 2, that is the equipment selection, sizing calculations, and the case study with help of the simulation ETAP software that we will discuss about the module number 2, right? The module number 3, SLD for the grid solar wind substations, AIS, SLD for the GIS type substation, cable selection, sizing calculations. This module 5, the 6 is the layout drawing, 7 is the earthing calculations. The earthing also required that we need to do because it is written here. Earth mat design calculations and earth mat layout. So the earthing also we will study with help of the standard. Module number 7, this installation lightning protection and DSLP calculations, it is required here, the DSLP calculation, the drawing, so that we will study in the module number 8. 9, transformer selection, sizing, protection. The transformer is the heart of the substation, so for sure we will discussing about the, and that is the reason we have take transformer in a separate module, that we can have study in the detail about the transformer, because that's the heart of the substation and that is the most costly equipment in the substation and most protection required for the transformer. Most selections we should know, the proper selections required for the transformer, since it is costly, that's the reason. So that we will discuss module number 9. Then 10, lighting designing for the illumination of the system. Then transmission and distribution line, that we will discuss. Okay, protections of that substation equipment, that we will discuss here, module number 12. Coming on 13, this battery and battery selection, sizing calculation, it is also required. Battery charger, this battery document you can see here, battery and sizing calculations, and it is also required in the job descriptions. The battery system, knowledge of auxiliary AC and DC system. So DC is achieved by the battery only, so that also we will discuss about the battery. And then we have the project. So these are the about the design modules. Now the project design engineering drawing preparation. So we will share you, all of you, one live running project. Whatever you are learning from us, do the practice on that project and make the drawings, submit us. We will review whatever you have prepared and what should be prepared, what is the standard, and what you have prepared, what is the gap between that. So we will have the review also. Project tender, we will share the drawings you have to prepare. Okay, so that now here module 14 you will do only, I will review and make the comment on your drawing preparations. Module 14, then next, so up to here we have the designing part. Now we are coming into the project engineering part. So the designing, project and tendering, these 3 most office jobs that we are covering the project engineering also. So in the project engineering, the equipment purchase or inquiry, specifications, preparation, review method on the vendor commercial offer, how to review the vendor commercial offer, The technical comparison sheet between when we have the more than 2 vendors, so we have to make one comparison sheet between the different vendors, so that how to prepare this comparison sheet, technical and commercial, so that we will discuss, and we will share the format also, that how we will make in that format. Then we have module 16. In that we will discuss about the BOQ estimation of the project, how to estimate the quantity, bill of quantity or the equipment quantity, and based on that the tendering team will estimate the cost. So we'll do the bill of quantity discussion, preparation for the project. So designing, project and tendering. Now we'll come on the system studies based on the ETAP. So ETAP, software introduction, load flow, power flow, and this. Then we have this short circuit, then relay coordinations, and these are some documents that we will share with all of you as a reference, so that you can use in the future whenever required. So this is the recipe and the background of this complete syllabus. Hope it is clear. Or any doubt in the syllabus, please let me know. And we will take one module at a time, and we will complete that module, then we will go to the next module. So the module wise we will going to study right now. Any query on this syllabus, what cover, what not cover, please, if you have, let me know. Yeah, yes, Bharti, we will share the related software as well. Yeah, I told ETAP, AutoCAD, I'll share, and the dialects also that we are covering. So we will share that. Yes, we will share. Okay.
Excuse me, sir.
Yeah.
Sir, does this cover only Tnd part, or it covers generating part also?
In the generating part, we have the ETAP system. So we'll take the simulations with help of the ETAP. Generating part, like what happens in the generating part, we are doing the generations from the thermal. So there is a process in the thermal. We have like mechanical and the other instrumentations and the electrical combinations. So what we are doing here, that we are covering the Tnd, but yes, we will cover the the generation, but not in the detail, in the briefly. Tnd in the detail.
Yes.
Okay.
Yeah. Sir, AutoCAD 3D or 2D, sir?
AutoCAD 2D is enough for the project. Yeah. So that, yeah, Bahadur.
Yeah, only for the plan this 2D is the enough, but we need nowadays this 3D also, because the major of company are using in 3D. But for the 3D model, we are using this Revit. You know Revit is 3D model. You know about that one? This Revit is
it's a Bahadur. So let me clear that since the project is the drawings made as of now in the 2D only, so we are covering the 2D in the detail. 3D if time permits, so we can go on that.
Yeah,
okay, right now.
Right.
Okay, and Bahadur Saini here, we have one engineer, so like AutoCAD classes he will deliver.
Yeah, when will we start, sir, that one?
We'll go first. Let us have 1 or 2 module.
Yeah, little bit we are interested about this.
Yes. First, let us understand how to do the selection, how to do the sizing calculation. Then we'll go on the preparations.
Yes. Okay.
Yeah, sir. Yeah. What about the earthing system in the CV job description? Is this available?
Yeah, available, na, Suresh.
Yeah. Can you repeat? Can you go back where it is?
Yeah, Rabbit MEP, correct, Gurjit. Yeah, I think like in the syllabus you were talking about Suresh.
No. I mean the job description I'm asking.
Yeah, they have I think they have written or not written, but they will be required that thing, na. EHV SLD, okay, plan section, EKD, currency diagram, equipment size, calculations, technical specifications. They have not written here, but it will be required. Why it is required? Because it is required in the project.
Yeah.
No?
Where is in our system? Where is in our syllabus? It is there.
In our syllabus we have this module. 7 earthing calculation and drawings equipment earthing by help of the IEEE, and the case study with help of the ETAP.
Okay, great. Thank you.
Yeah. So this is the syllabus that we will discuss. Okay, and yeah, as the Gurujit replied that we use the Revit mostly in the MEP industry, but yes, we will, if time permit, we will take some snaps, some look of the Revit also. Okay, so this is the syllabus that we have now. Hope the background of the syllabus is clear to everyone. Okay, so course content introduction we discussed with the proper justifications, why this course coming, why this content we are going to discuss. Okay, so process of the training program workshop, how this process we expect. So since this is live project based training, so therefore project hands-on practice is important. So we have 3 days classes in week, alternate days like Monday, then Wednesday and then Friday, and remaining days practice on project. Develop the drawing and document list for the construction of the project and submit us for review. And whatever you are taking the class, make one summary report, one summary sheet, and that summary sheet will help you for the interview preparation. So that is the expectations from all of you. Make the learning summary sheet, submit us for review, so that we can make correction if anything in there, and take project and do the practice on that project, so that this training should be the hands-on live project based training, and that's the reason. So that is expectations to all of you, that you will prepare the learning summary sheet and you will work on the project. That project we will share. Okay, so objective of this course is the course covers the substation, Ais and Gis, design engineering, transmission line, ETAP as a simulation software tool, and AutoCAD as a drafting software with live project practice. So that is the main objective. And we discuss about the course content, and let us inform all of you about ourselves, about us. So we are an engineering consultancy firm providing design engineering services from 11 kilovolt to 765 kilovolt substations, and ETAP system studies services in India and international customers, and the real-time training to corporates and the professional engineers. So that is about Bharti, that Monday, Wednesday and Friday, that will be the class test. Okay, and for every class I will share the link on group, so that you can join by that link. So that is about ourselves. And
Where is your office located?
That in the Pune.
Pune.
Yeah.
Do you have any branches in South?
As of now, no. We are planning to open a branch in Delhi NCR region, because we are executing mostly project for the power grid for the PGCIL. So their office is in the Gurgaon. So we are now moving another branch in Gurgaon, like in the Delhi NCR. So that we are doing. But as of now, we are like operating from Pune only. And we have
actually got the Andhra Bank credential. I got
actually that Andhra Bank is everywhere, not only in the south.
That is true.
Yeah. Yes. Okay. So this is about ourselves. We have one tie-up in the one company that.
Can you what about yourself, your background, something you can tell about?
Okay, so we will keep 5 minutes and we will have introduction with all of you and with myself. I'll come on that. So what is the project that we have executed? So we have executed the project for the complete design engineering of 500 by 230 kV substation for the PGCB Power Grid Company of Bangladesh, and we have done some project for the PGCL India also, and we have done some owner engineer as a OE, like 220 by 33 kV substation project for the Alfanar, that is the Saudi based company, Alfanar Construction. And then we have done some pre-bid engineering support for the Tata Power, their Noida office. So there is 12 number substation packers rating 400 by 220, 132, 220 and 132 kV for TBCB Jharkhand project. So for that we have done the pre-bid engineering support to Tata Power Noida. So that is our few executed work that we are doing. So basically we do this the project, and parallelly we provide the trainings. So on project we take whatever project we are working, and the same project we forward to participant also, and we provide some real-time training. So this is about the training program, about the introduction about this the company and the project. And myself is Raghav Tripathi, and I have 12-year experience in this field. I started my career from the this Alstom, and then I was part of the GE. The GE took over the Alstom, so I was in the GE. And after that, I work in Tata Group. And after this, I'm working in the IETP as a consultant. So this is about my profile. And can I have like some introduction about the participant, like some?
Yeah, 1 second, Raghav. Before that, I have one doubt. Actually, in the substation, for the making the substation flooring, is there any topic you are going to cover? Substation, how we have to gravel that?
Yes. So Resh, whatever for substance, everything we will going to cover. Don't worry. The gravels, the thickness of gravel, why gravel required. Okay, what should be the resistance of the gravel? That is 3000 ohm meter gravel required. The resistance required for the gravel. Thickness, that is 50 to 150 mm thickness required for that gravel. Okay. So purpose, the purpose of the gravel to increase the contact surface resistance and to decrease the step and touch potential. That is the use of the gravel in the substations. Okay.
Can you repeat me? Can you repeat again, please?
The purpose is to increase the contact surface resistance and to decrease the step and touch potential. Okay, that's why we do the gravel. The same purpose we use the insulating mat. The insulating mat we use inside the panel, right? The insulating mat. So the purpose of insulating mat is what? To increase the contact resistance, contact surface resistance, and to decrease the step and touch potential, right now. So the same insulating mat we have the insulation gravel. We'll cover in the details, Suresh, don't worry.
Yeah, just I recall in my mind that.
Okay. So don't worry. Yeah. So can we have introduction about you, Suresh?
I will start myself. I'm Suresh. I'm from Andhra Pradesh. I have done my engineering graduation in Tamil Nadu. I have completed BE in Electrical and Electronics Engineering in 2008 from Anna University. And thereafter I joined in Hyderabad. I worked for 4 years in PowerTech Private Limited as an electrical engineer in panel boards, LED panel boards.
Okay.
Then I moved to Bombay for 6 months in Marine Electricals India Private Limited as a design engineer for the LED panel boards only. Then afterwards, in 2013, I moved to Gulf in Muscat, Oman.
Okay.
We must be knowing Oman.
Yeah. So we are working separate in the Oman also. I'll share you.
Yeah, great. Maybe you may take my help also if anything is there, we will work together.
Yeah. We are working.
Business, our team also, maybe some of our team also working in Gulf, I think. Somebody.
Yeah. We have.
Class team. Yeah. And we are right now we are the Schneider Electric channel partners, LED station boards. Since 2013 I am working in Muscat. Joined as a design engineer, now I am looking over entire operations from sales to after sales service.
Okay.
All the executions. Yeah. This is my short introduction. I got married. I have blessed with 2 babies. 2 kids.
Okay.
Yeah.
Thank you. Thank you, Suresh.
Thanks for this. Yeah.
Thank you. Yeah. Next. Anyone, please come out. Let's have a brief about. Yeah, Abhishek.
Hi, Abhishek.
Yes.
My name is Abhishek. I'm from Rajasthan, and I did electrical engineering from Rajasthan only. And then after I joined the renewable sector, and I completed 6 years in renewable sector.
Okay. That's great, Abhishek. Thank you. Yeah, Bharti.
Hello?
Yeah. Yes.
Bharti Mule. I am from Tamil Nadu.
Yeah.
I completed my engineering in 2004. I started my career as a site engineer. After that, I moved to Saudi Arabia. I worked as a plant engineer. At present, I am working in Chennai as a project engineer. So I want to recall my engineering friends so that I choose the course.
Okay, thank you. Thanks. That's great, Bharti. Yeah. Thank you. Yes.
Hi everyone.
Yes, Syed.
Hi everyone. This is Said. I'm from UK. I work for SSE, Scottish Southern Energy. I'm quite an overhead line expert in that company at the moment, as working as a subject matter expert for overhead line. I worked in Saudi Arabia and Oman. The reason for joining this course is I don't know anything outside where we finish at Gentry. So I think this course, the reason for selecting this course was it was mainly very rich and dominated in substation. So I want to acquire knowledge in substation. And by the looks of the course content, is quite thorough in that. So that's my reason. I will be joining calls from UK, which is 4:30 in the
Yeah.
yeah.
Yes, Syed. Yeah. Thank you. Thanks.
Thanks.
Hello.
Yes, Nadeem.
Greetings to Raga sir, firstly, and to my all friends present here. So my name is Nadeem Hussain. I live in Srinagar. So the purpose of joining this course was to get familiar with some of the prominent softwares that we will be using here. Besides the MATLAB that we have used, I have used in bachelor's. So yeah, I'm looking forward to interact with and learn some of the practical aspects of this power engineering.
Yes.
Thank you.
Sure. Thank you, Nadeem. Yeah.
Hello.
Yes, Gurjit.
Hello. Good evening, all. Myself, Gurjit, I have completed my engineering in 2008, and after that, I joined Stream Electric Limited. It is basically a master-based company which is working on the EPC projects. And after that, I joined for 220 kV substation. But at that time, I was fresher, so I didn't know much about the substation designing.
Okay.
After that, I changed my field to operation and maintenance. And in 2011, I shifted to UAE, and here I'm working in a pattern manufacturing plant. So,
Okay.
just my basic idea is to join this course was to refresh my technical knowledge, so as to increase my knowledge with regard to the design of the substation.
Okay, Gurjit. Thank you.
Hello, sir.
Yeah, Nirvan.
Hello.
Yeah, Devarpan. Yeah. Go ahead.
Okay, sir. Hi, everyone, and Raghav, sir, especially. Thanks for the course. And I'm from Siliguri, West Bengal, and I have done my BTech in 2016. Later, I joined one company called Pioneer Construction in Assam. There, I worked for around 1.5 years, and as a maintenance engineer of 400 kV transmission line. And then I joined Jebtech Infratech Limited in Delhi. There I worked as a currently I am working there as a licensing officer. But sir, basically I want to switch my career in design sector, so I choose that course.
Okay, Devarpan. Thank you. Yeah. So we will work for that. Yeah. Sure.
Thank you, sir.
Yeah, can we have like 1 or 2 introduction, then we will move to the
Hello everyone.
Yes, Chandan.
This is Chandan Mishra. I'm working in Excel Limited from 3 years as a physical engineer.
Yeah.
And I have completed my graduation from NPTI in power engineering.
Okay, that's great. Okay, thank you. So
hello.
Yes.
Hello everyone. I'm Ismail from basically from Pakistan. Currently I'm working in KSA with one of the Chinese companies as an operation and maintenance engineer. And I have this course is to learn about the design.
Yeah, sure, Ismail. So, okay. So,
hi everyone, I'm Abdullah Khan. I have completed my graduation from Punjab in 2018. Now I have joined Oasis Techno Engineers Private Limited, that is based in Noida, and it's basically testing and commissioning uh, is doing right now. So now I am a commissioning engineer. I have 3 years experience right now. So I am doing the project in right now on GIS. So my main motive is to do this course is like as I want to do like office job or as a design engineer, and basically I want to move from out of India, like or Gulf or European countries.
okay,
So
okay.
that's why, yeah.
So we have Gulf students. You can approach.
Okay, let me see that anyone help me, then that will be good for me.
Yes, sure.
Okay, thank you.
Thank you, Abdullah. Thank you.
Hi, this is Raghunath.
Yeah, Raghunath.
Actually, I joined this course because everyone has their limitations in working places. Like someone has design field, someone has project, someone has maintenance, O&M like this. But even though we have a lot of experience of 12 years, 10 years, 6 years, but some doubts keep always revolving in mind. The basics like what's the harmonics, what's the frequency, what's the AC, DC, something.
Correct.
So my reason is that I have to know everything. Reason what exactly
Yes.
as you said earlier, the size of the chip, size of the stand, size of the sensitivity, whatever it is. So I have to know the each and everything reason of the electrical design project or whatever it is. That's my intention to join this. Thank you.
Sure, Raghunath. So we will take the ETAP software, Raghunath, and through that we will do the simulations, and we can understand in the details.
Sure. Thank you.
Yeah. So what the harmonics? Why harmonics is coming? How to mitigate the harmonics? Why third harmonic is most dangerous out of the fifth, seventh? Why third harmonics is most dangerous? And so we will discuss through the ETAP. Okay. So you will get clear.
Yeah, hello all.
Yes,
this is Shubhendu Mishra. I'm currently associated with Siemens Limited and looking after the project manager for the relay retrofit and revamp business for the complete India. Looking forward to this course for tomorrow.
Sure, Subhendu. Okay, so any other would like to? Yes,
hi everyone. This is Sheikh here. I have completed my BTech in electrical engineering in 2015. I have overall 6 years of working in electrical field, including 2 years in power transmission distribution projects, and now I am working on a steel plant in Saudi Arabia from last 2 years. And my purpose to join this training program because I want to make my career in substation design field. That's it.
Okay, sick. Okay.
Yeah.
Okay. So other participant we can have one another introduction session so that we can like familiar with others. Okay. So thanks all for the joining this program, and this program syllabus already we have taken what we are going to discuss. This board we will take. Yes, we will have on Monday. This board we will take to explain the topics that what we are going to discuss. So this board will be our reference. Plus, along with this board, we will take the IEC and IEEE standard. Across the globe, across the world, we have only two standard, international standard. The IEC and the IEEE. This is most adopted international standard. So we will take the IEC and IEEE standard as the reference, plus site picture as the reference, plus some drawings and some videos also will take as the reference. So we'll discuss the complete concept with standard, with site picture, with videos, and with the ETAP software, so that everything will be clear. And plus the project technical specifications, that we will take one project technical specifications, and for on behalf of that we will discuss the topics. Okay, so we have the classes on Monday, Wednesday and Friday. Timing will be same, like 9 or 9:30 to 11, or 9 p.m. to 10:30. This will be the timing, or we can go to the 9 p.m. to 11 p.m. Like this, we will have the timing. Link we will share in the group, so through that link you can join the classes. Okay, so any questions for me today, or we can wind up for the today's sessions and we can start the module number 1. That is the first module from the Monday onwards. Yeah, come again, Bharti.
So any hard copy documents you will share, or
we will share, Bharti. We will share the document. All these IEEE standard I will share with you.
Yeah. Okay. Thank you.
Yeah. You test me your email address, and whoever not received, please test me email address. I will share the document. So what I do that I'll this module number 1, these modules, what PPT, what document, what reference material. So I will share on your email ID. You can use as a reference. So I'll share the documents, the class study materials, the class data, along with the IEEE standard, the calculation sheet, the drawings. We will share. Okay, please test me your email ID. I'll share on your email. And some student I have already said, so they no need to share. Other who have not received, please share. I'll send him on this weekend. Okay, so let's wind up today's session. And today was the introduction about the syllabus, introduction about me, and about the company, about the participant. That was the agenda for today. So any feedback or anything that you wanted to say, anything, or we can now close.
You have any tie-up with the companies for the placements? You have any
Actually, Suresh, what we work as a consultant, so we have tie-up with the EPC companies. Okay, so that EPC company we can assist in that EPC company.
Right.
Yeah.
Sir, will you also send this record session?
Oh, Raghunath, I'll try to send you. Okay, the record session. I'll upload on Google, and that I'll make the link and I will share with you.
Okay.
Yeah.
Hello.
Yeah, it is. Yeah, it is.
This course covers the testing part also.
Testing, for the testing and commissioning part, I'll share you the document, Ritesh, that you can go through. I'll share you the Power Grid document for the testing and commissioning that you can go through.
Okay.
Yeah.
Do you have any training part for the testing and commissioning, like other training module?
Yeah, we have Gurjit. So I'll share the document, the syllabus for that.
Okay.
Yeah. Okay, so thanks all of you for the joining this training program, for joining us. So we'll.
Thank you so much.
Thank you. Yeah, thank you so much, and we are looking forward for this training and learn new things and get associated with.
Sure, Subhendu.
Only one doubt, do you provide any certificate also?
Yeah, Bharti, we will provide you the certificate. The course completion certificate we will provide in the last. Sure.
Yeah.
Sir, do you conduct any exam like this to get?
No exam. The assessment only we will do.
Okay.
Yeah. So we have next class on Monday. Okay, Monday agenda will be, we will download one project from the website, download the live tender from utility company website, or we will select some project as the reference, and that project designing we will do in this 3 or 3.5 month. So we will download the live tender from utility website, and we will study first of all how to study the tender, how to read any tender project. So that we will study on the Monday. And what is the process involved for the construction of project, that we will study. The design process we will study, and how to start designing work, what is the flow chart, so that we will study, and what is the list of IEC and IEEE standard, that we will study, and how to select the system design parameters and design basis report, so that we will study to next week. Okay, thanks all for the joining. Good night.
Thank you, sir.
Thank you. Bye-bye. Take care.
Thank you.
Thank you.
Thank you so much.